Hello students, in previous video we discussed what do you mean by OSI reference model and what are the layer architecture of OSI reference model. In similar to that, today we are going to discuss what do you mean by TCP IP model. So let's start. In this session we are focusing on introduction and architecture of TCP IP model, differences between OSI reference model and TCP IP model, and at last we are going to discuss what are the advantages and disadvantages of TCP IP model. TCP IP means Transmission Control Protocol and Internet Protocol. It is the network model which is used in current internet architecture, and it is actually developed by Department of Defense Project Research Agency, which is also known as ARPA. Now later on it is also called as DARPA also. The main feature of this model is it supports a flexible architecture. That means what? We can add more number of machines, or we can add or we can modify more number of hosts or systems into the network, and it has basically 4 layers. To show what are the protocols and networks used in TCP IP model. So as I earlier said, TCP IP model uses 4 basic layers. So those are nothing but physical plus data link layer, network layer, transport layer, and application layer. So here network layer, transport layer, application layer, these are going to use protocols. What do you mean by protocols? Already I have explained in previous sessions, or I have explained in OSI reference model. It is nothing but an agreement that governs the communication between the host computers. And physical layer plus data link layer, it is also called as a network access layer, which uses certain networks called as ARPANET, SATNet, packet radios, and local area network. So here the application layer uses a certain protocols called as terminal network, that is telnet, FTP, file transfer protocol, SMTP, that is nothing but system mail transfer protocol, and DNS, that is domain name system. Similarly, transport layer uses TCP and UDP. TCP stands for Transmission Control Protocol, UDP stands for Unified Datagram Protocol, and network layer uses IP protocol, that is Internet Protocol, that what we discussed in previous model. So this is nothing but how the TCP IP model layer architecture looks like and what are the protocols and networks it uses. To compare the OSI reference model with TCP IP conceptual layers. So as we discussed, OSI reference model uses 7 layers basically, starting with the physical layer to application layer. But wherein which TCP IP conceptual layer, it has been reduced to 4 layers. So here the combination of application layer, presentation layer, and session layer has been merged as a single layer called as application layer. Transport layer kept as it is as a transport layer, and the network layer also kept as it is as a network layer. And the network interface layer, it has been merged by using a data link layer and a physical layer. Already in previous sessions we discussed what are the functionalities of each and every layer of OSI reference model. So here also the same functionalities are going to carry out with the TCP IP conceptual layer, except there is some few differences. Then how TCP IP model works. So normally what happens, the sender tries to send his message to destination. So the entire message will not travel through the network as it is. What happens here? TCP protocol, it will break down the entire message into the number of packets. Assume that I am going to send some sentence. Okay, so this sentence will be divided into the number of packets. So each packet will be assigned with a sequence number, and it will store the source IP address as well as the destination IP address. So why it is required? Because it has to, each and every packet has to reach the right destination. This is the main intention of a TCP IP. And what happens, assume that my message has been broken down into several packets. Say for example, the same message has been broken down into 10 different packets. So these packets will be assigning the numbers, and it will store the destination IP address as well as the source IP address. So these packets will travel through the network. So here what happens, during the transmission, network uses the router device. Router device is nothing but the hardware device which is used to read the destination IP address, and it will try to reach or it will try to deliver the package to the right destination. So here in the network there might be chances of a network traffic, or there might be the chances of losing a packets, whatever it may be. So it will follow different routes. So this is the task of a router. So router has to decide on which route the packet has to travel. Suppose from router A to router B, say for example that path is busy with some other packets. So my message has to get transferred immediately. So router, what it will do, it will look into the traffic and it will reassign the another route to the packet. Ultimately all these 10 packets, it has to reach the destination successfully. So this is the first part. After reaching the destination, what it has to do, TCP protocol, it has to reassemble, it has to re-sequence the packets which are received at the destination side, so that destination system can read the entire message successfully. So this is how TCP IP works. Okay, now let us try to understand what are the functionalities of TCP IP layers. So the first layer is application layer, which is nothing but the layer which is closest to the end user, through which user is going to send, or he is capable of reading the message which has been sent by the sender. So it interacts with several application programs, like it may use web browsers, or it may use messengers, or it may use Skype, etc., etc. So it is going to provide various email services also, so that sender can send his messages very easily, and also he can read the messages very comfortably. The layer is a transport layer. The main functionality of a transport layer is it divides the message which is received by the session layer into the number of segments, and it is going to assign a sequence number for these segments so that it can reach in the right sequence order at the destination. It also has to determine where actually these data segments have to be sent, and where it has to be sent, and at what bit rate it has to reach. It also ensures that the data, whatever it is going to send through the network, it must be error free, and it is going to offer an acknowledgement for the successful submission of packets. Suppose if it receives negative acknowledgement, that indicates that there might be something wrong with the packet delivery. At that time what happens, it makes once again it makes transmission process to reach the segments successfully to the destination. So this is what the most important functionality of a transport layer. Next layer is a network layer. It is also known as internet layer. So this uses routing algorithm and address assignment protocols so that the packets can reach the correct destination irrespective of the network or irrespective of the routes the packets travels. The layer is network interface layer, which is also called as network access layer. It is the combination of a data link layer as well as a physical layer, what we have discussed in OSI reference model. So this layer defines how these data should be sent physically through the network by using a certain hardware devices. It might be connection oriented or it might be connectionless oriented. Okay, now let us have a look on what are the major differences between OSI reference model and TCP IP model. The first major difference is based on the development. Who developed OSI model? OSI model has been developed by ISO. ISO stands for International Standard Organization, wherein which TCP model has been developed by ARPANET, that is Advanced Research Project Agencies Network. OSI references to Open System Interconnection. TCP IP refers to Transmission Control Protocol and Internet Protocol. OSI follows a vertical approach of a communication, wherein which TCP IP follows a horizontal approach of a communication. OSI reference model has 7 basic layers starting with physical to application, wherein which TCP IP has just 4 layers. So in OSI model, the transport layer only uses connection oriented for communication, but in TCP it uses both connection oriented as well as connectionless oriented. The last difference is in OSI model, the data link layer and physical layer, these are implemented separately. These layers are separate in nature, but in TCP what happened, the physical layer and the data link layer has been combined as a single host to network layer, that we call it as network access layer. Now let's have a look on what are the benefits of TCP IP model. The first benefit is it helps us to establish or set up a connection between the computers which are residing at a different network. Through this, it also enables inter-networking between different organizations. It operates independently of operating system. I may use Windows, my friend may use iOS, or he may use a Linux operating system. It doesn't mean what kind of operating system we are going to use, but it is having the capacity to operate irrespective of operating system. It also supports many routing protocols. Through this, our packet segments travel through the network and it will help in reaching the right destination at the right time. And through this, it is going to reassemble those packets in the right sequence. And the last important benefit is TCP IP model. It has a highly scalable client server architecture. Through this, we are able to add or we are able to easily modify the networks by adding or modifying the computers within the network. So these are the benefits of TCP IP model. Now let us understand what are the disadvantages of a TCP IP if we compare with the OSI reference model. TCP IP is the most complicated model to set up and manage the network. In this model, the transport layer does not guarantee the delivery of packets. So here the replacing protocol in TCP IP is not so easy because it has no clear separation form of its services, protocols and interfaces. So if we compare with the OSI reference model, in OSI reference model it has a clear-cut layer functionality is available and it is having its own protocol to follow. But here what happened, those layers has been combined together so that there will be no clear separation forms of its services and interfaces. So these are the disadvantages of a TCP IP model, we can say. Yes, I just conclude this video. Thanks for watching. If you like this video, please like, share and subscribe. Thank you.